Welcome students. I welcome you all in this online class. Today we are going to study photochemistry of carbonyl compounds part 3. In part 1 and part 2 we have already discussed two of the most important reactions of photochemistry of carbonyl compounds, and they are photoreduction and Paterno-Bucchi reaction. Today we are going to discuss one more, a very important reaction, that is Norrish type first reaction. So Norrish, the name of a scientist. In the part 4th video lecture we'll be discussing Norrish type second reaction. So today we'll be focusing only on one reaction, that is Norrish type first reaction. The excited N-pi star saturated acyclic carbonyl compounds undergo an initial cleavage of carbon-carbonyl bond to give an alkyl and an acyl radical, and this process is known as alpha cleavage or Norrish type first cleavage. The photolysis takes place generally in vapor phase. The bond dissociation energy of a carbon-carbon bond adjacent to a carbonyl is comparatively small, and consequently photochemical excitation of ketones usually results in the homolytic fission of the alpha carbon-carbon bond, and this is known as alpha cleavage. The most thoroughly studied example is acetone, which has been photolyzed in the vapor phase as well as in the liquid phase. Absorption of light results in the formation of an N-pi star excited state of acetone, which undergoes a carbon-carbon cleavage and yields a methyl radical and an acetyl radical. So here you can see in the equation part, acetone on irradiation forms methyl radical and an acetyl radical. At room temperature, two acetyl radicals combine and form biacetyl. So here you can see in the equation twice CH3CO, that is acetyl radical, two acetyl radicals combined together and a biacetyl is formed. At temperatures above 100 degrees, acetyl radicals decarbonylate. Decarbonylate means loss of CO, that is carbon monoxide. So at temperatures above 100, acetyl radicals decarbonylate with the production of ethane and carbon monoxide. So here you can see in the equations, first equation is acetyl radical gives rise to methyl free radical plus carbon monoxide. Two methyl radicals combine together and form ethane. Now this was the case of a symmetrical ketone. Acetone, we were discussing acetone, which is a symmetrical ketone. Now let us see a few more examples. And this time we'll be discussing the case of unsymmetrical ketones. Now if we consider unsymmetrical ketones, splitting takes place in a way that more stable of the two possible radicals are generated. So now let us consider a few more examples. So here two examples are discussed, A and B. So in the first example, you can see a ketone, that is 2-butanone. On absorption of light, acetyl radical and ethyl radical are formed. In the next step, acetyl radical combines, two acetyl radical combine together and a biacetyl is formed. Also, ethyl radicals combine together and form an alkane. And here, since two ethyl radicals are combining together, so a butane is formed. Now, let us discuss the B reaction. So here also, this is a case of unsymmetrical ketone. On absorption of light, again acetyl radical and alkyl radicals are formed. Again, acetyl radicals combine together to form biacetyl and alkyl radicals combine together to form alkane. Both the singlet and the triplet in pi star excited states are capable of undergoing alpha cleavage. Now, if we consider acetone, most of the excited singlet molecules undergo ISC, that is intersystem crossing, to T1 at room temperature, but intersystem crossing is less with increase in temperature. And thus, both the species, that is singlet and triplet, participate in Norrish type first reaction. Similarly, at the room temperature, nearly half of the molecules of diethyl ketone react in the S1 state before the ISC, that is intersystem crossing, to T1 occurs. Now let us discuss one more example of Norrish type first reaction, that is alpha cleavage. So again we have taken an example of a saturated acyclic carbonyl compound. The excited N-pi star saturated acyclic carbonyl compounds undergo an initial cleavage of carbon-carbonyl bond, give rise to an alkyl and an acyl radical. We have seen it just now in the earlier examples also. And this is alpha cleavage. Now you can see in the equation part. So first is the structure of a carbonyl compound, that is a ketone. It absorbs light and the formation of acyl radical and alkyl radical takes place. The radicals formed in Norrish type first cleavage follow one of the following three routes. So the first route is alpha hydrogen abstraction from acyl radical to alkyl radical. The second is decarbonylation, that is loss of CO, carbon monoxide. And the third one is hydrogen abstraction from alkyl radical to acyl radical. So let us discuss these three different routes one by one. So the first one is alpha hydrogen abstraction from acyl radical to alkyl radical. So here you can see in the equation part the acyl radical plus alkyl radical. So here Alpha hydrogen abstraction takes place from acyl radical to alkyl radical, which leads to the formation of ketene and alkane. The presence of ketene can be detected by spectroscopic method, or the presence of ketene can also be detected in the presence of a nucleophilic species such as water or methanol. It is converted into carboxylic acid or ester derivative and gets tripped. So by these methods we can easily detect the presence of ketene. Now let us see the second route, that is decarbonylation means loss of CO carbon monoxide. So here you can see again acyl radical is losing carbon monoxide and alkyl radical is formed. And in the next reaction, alkyl radicals combine together to give rise to alkane. Now let us discuss the third route. So third route is hydrogen abstraction from alkyl radical to acyl radical. So here you can see in the equation acyl radical plus alkyl radical. So hydrogen abstraction is taking place from alkyl radical to acyl radical, which leads to the formation of aldehyde and alkene. So we have discussed few examples of Norrish type first reaction today, that is alpha cleavage. You can do more examples. So that's all for today. In our next video lecture, we'll be discussing Norrish type second reaction. Thank you so much.